What I want to look at and discuss here is the expansion of double brackets, where each of the brackets themselves takes a linear format. So what we're doing is we're talking about each bracket looking of the format ax plus b, some sort of linear function. And what we want to do is, if we're taking the product of two of these brackets, we want to ask ourselves how we go about expanding those. So the ultimate question is, how can we expand our skills into expanding a pair of brackets that look like this? Both linear functions. How do we expand it? Well, there's two methods I'm going to discuss with you. One method uses the acronym FOIL. Another method uses a table expansion. Now, if I were to look at the acronym FOIL, the F-O-I-L. Each of these letters stands for a different part of the function. F means first. What that means is we take the first element of each bracket and we multiply them together. So in this case, x times x, which gives me x squared. O means outer. That means the outer elements of the bracket, so these two indicated here, which means I'm going to do x times 3, and I'm going to get 3x. Now, a key thing to note is I haven't written any signs there, and I'll explain why to you in just a moment. Signs are still important like they were before, but there's something I'll explain in just a second. I, for inner, means I'm going to multiply these two inner elements together. So in this case, I'm going to do 1 times x, which quite simply gives me x. And then L means last. The last two elements of the brackets go together. So in this case, 1 times 3, which gives me 3. Now what I have to do is I have to put all of these elements together to give myself something. Now, we know, or we should know, that expanding two linear brackets in this manner is going to give us a quadratic function. So what we need to do is, when we get it, and it looks like this format of x plus something, or ax plus b, cx plus d, we're going to get a quadratic. Well, in this case, I've got x squared. Now, I mentioned before about the signs. There is nothing in front of each of these elements here when it comes to the O, the I, and the L. If there's nothing there, that means we're adding them. So we then get plus the x, plus an x, plus a 3. And what we can then do is, you'll notice that we're able to simplify that by adding the 3x and the x, so these two central elements, together to get x squared plus 4x plus 3. Now, if either of these two constants at the end, or either of these two parts, when we come into it, and you might look at brackets where there's letter elements there, if either of them were negative, we'd take the negative with it. So if this was an x minus 3, for example, my x times 3 would actually become x times negative 3, which would give me minus 3x, which means I would take the negative with me, and this would have become x squared minus 3x plus the x plus the 3, and I could have simplified from there. So if there's negatives, watch out for it, but it's not a great stretch. I could have used a table expansion. Now, the table expansion has certain benefits at times compared to using FOIL. The reason being, the table expansion, what we'd want to do, remember the row across the top and the column that's at the start, we put a bracket in each way, but we take the sign in with it. So taking the sign in with it will help us to deal with the signs as we approach the question and as we go through it. Each element in the box is the product of the row and the column on the outside. So top left box is x times x, which gives me x squared. Top right, x times plus 1, which just gives me plus x. Bottom left is plus 3 times x, gives me plus 3x. Bottom right is plus 3 times plus 1, which gives me plus 3. And you'll notice that each of the elements in this one are the exact same as the elements once I've expanded using FOIL, which means that when I simplify it, I'll end up getting the exact same answer as what I got before. So two different methods and variations and ways of expanding them. They both follow the same structure every single time we do it, regardless of what elements are in the brackets and what the brackets look like. The key thing you now have to do is make sure you pick the method that works best for you. Now, a key point to make is these aren't exhaustive. These are not the only two methods. my opinion, these are the two best methods for expanding a double pair of brackets in this manner. If you're aware of another method, feel free to use it. Just make sure when you show you're working for it, you're showing you're working clearly in an examination and clearly when it comes to an exam paper, so that you don't cost yourself any marks that you should be nailing every single time. So a couple more examples for you. I'm going to use the FOIL on the first one. I'm going to use the table method on the second one, just to show you how I can apply it to anything. So if I looked at this first one and I wanted to expand it using the FOIL technique, I'd look at first, outer, inner, last. So F first element of each bracket together. So that gives me 2x times x, which gives me 2x squared. O for the outer, that's 2x in the first bracket. And that's then going to be times 3. That will then give me 6x. I'm then going to look at inner. So my inner is these two elements here. Now, you'll notice the first bracket is 2x minus 1. That means the inner elements are going to be negative 1 times x. This is where the sign comes into play, and we have to be very careful. Negative 1 times x gives me minus x. And then last elements, L, is going to be negative 1 times 3. Again, the negative goes with the 1. It doesn't just go one time in the I, and then that's it. It goes every single time we use it. And that'll give me negative 3. What I'm then going to do is use all of these and combine them to write my expansion out of 2x squared plus 6x. Remember, if there's nothing in front of it, once we've done this, it's an add. I've got minus x, and I know that because it's minus x there, minus 3. And then at this step, if I can, I simplify it, and I'll end up getting 2x squared plus 5x minus 3 is my solution. And I got the same answer if I used the table method. That question, I'm just going to stick with FOIL. Second one I'm going to do here, I'm going to show you how we expand it using the table method. So this table gets set up the exact same way as we would normally. Set it up in this manner. Your top row is one of the brackets, so in this case I'm going to go for the 3x plus 1. Again, remember, take the sign in with it. My first column is going to be given by the other bracket, so in this case 2x, and I've got a minus 1 there. Each element within the table is given by the product of the row and the column, so let's fill it in. Top left is going to be the product of 3x and 2x, so that's 6x squareds. Top right is going to be the product of plus 1 and 2x, it's going to give me plus 2x. Bottom left is going to be the product of 3x and minus 1, so that's going to be minus 3x. Bottom right is going to be the product of plus 1 and minus 1, which is ultimately going to give me minus 1. And I can then write the elements out because that's now my expansion. I've got 6x squared plus 2x minus 3x minus 1. Simplifying that then, what I'll end up with is 6x squared. I've got plus 2x minus 3x. Take away an x, take away 1. So there you go. There's the solution when we come to expand the bracket. Either of these two methods works fine, and it works every single time as long as you remember, firstly, if you use FOIL, what the acronym means, first, outer, inner, last. Or secondly, that each element in the table, if you use that method, is given by the product of the row and column, and the signs go in with it so that we can eliminate any need for mucking about with signs later on, and is built into the question. What I'm going to do is I'm going to put up a couple of examples for you, have a crack at them, pause the video, and then I'm going to show you both methods work through for each of the examples, so you can compare them to whatever technique you decide to choose. So there you go, 4 for you to do that. You'll notice that last one has x's and y's in it, so that might provide you a little bit more of a challenge, but it's not too big a step away from what the first they are. So, pause and have a crack, come back and I'll show you. So here we go. First two examples there, that top row. If I looked at the 5x minus 1, the x plus 3. As I said, I'm going to show you both methods. So if I were to use the FOIL acronym, first, outer, inner, last. First would give me 5x times x, which is 5x squared. Outer would be 5x times 3, which gives me 15x. The inner would be negative 1 times x, which is minus x. And then the last would be negative 1 times 3, which gives me negative 3. If I combine it all, I then get the 5x squared plus 15x minus x minus 3, which would then simplify to 5x squared plus 14x minus 3. So if I were to use FOIL, that's how I'd lay it out and how I'd work it. If I were to use the table method, as is just below, I'd lay it out in this manner. So my top row, 5x minus 1, my column is x plus 3. Remember, you can swap them round. I could have had x plus 3 across the top, 5x minus 1 on the left. I've just done it that way because of the order of the brackets. So if you've got them that way, don't worry too much about it. You'll still get the same answer ultimately as long as you do the maths correct. We then follow the table product of row and column for each element. So that gives me 5x squared in the top left, x times negative 1 gives me minus x in the top right, plus 3 times 5x gives me plus 15x in the bottom left, plus 3 times negative 1 gives me minus 3 there. Then I'm going to expand it out and simplify it. So I've got 5x squared minus x plus 15x. Well, that just gives me the plus 14x I had previously. And then I've got minus 3. And lo and behold, my answer here, both the exact same as we'd expect. If we look at the second one here, again, example set up for both the FOIL and the table method. One thing you'll notice, I get the same answer regardless of each method I choose. So compare your one to whichever way the working is laid out for that, appropriate for you. Next two examples, the first one was involving the z, so 3z plus 5, 2z plus 3. Just because I've changed the variable name doesn't mean I changed the technique. Still works, so FOIL is still first, outer, inner, last. 3z times 2z, 6z squared. 3z times 3, 9z. 5 times 2z is 10z, 5 times 3 is 15, and it expands and gives me that simplified version, and it's the same in the table there. Rows and columns multiply together, and it gives me each of the elements one after the other, and ultimately the same overall solution for my final answer. Last one, I told you I had two variables in it, x's and y's. Now, just because it's got two variables doesn't mean my technique changes. The technique stays the same. I just have to really watch, one, how I lay out my products, and two, how I simplify my solution at the end. So if I'm using FOIL, my first elements are x and 2x, that will give me x times 2x, which is 2x squared. Outer, x times the negative 3y gives me minus 3xy. Inner gives me 2y times 2x, which is 4xy. And last is 2y times negative 3y, which is negative 6y squared. So putting them all together, I get 2x squared minus 3xy plus 4xy minus 6y squared. And if I simplify it, I get 2x squared. I can gather the xy terms together and get plus xy, and then minus 6y squared. And then the last one, there's a table version of that exact same method. First bracket's the row across the top, second bracket's the column. You notice each of the parts of the multiplication is still the exact same as what they were previously with FOIL, and the answer simplifies to the end the same. One point to note, and I've seen this sometimes in pupil working, is that xy term, sometimes they write it as y times x, so yx. Now you're not wrong with that, however solutions in working prefer you to go alphabetically. So you'll see xy written down. If you wrote yx, you're not wrong. It's just, it would get a squiggly wee line underneath it in your marking because it's not the alphabetical way, i.e. the standard format that we'd expect from it. So just be aware of that. You're not technically wrong, it just doesn't look nice. The OCD of mathematicians comes into play there. So, when we're expanding double brackets, which both the linear form, what are the rules? The biggest rule has to be determining the method you feel suits best. So the two I've illustrated here are FOIL, first, outer, inner, last, so we follow the letters for each part of the acronym. The second method I demonstrated was using a table, remembering to take the signs into it and dealing with them in the calculation. Third rule, expand it out, simplify and gather like terms where needed. The fifth one was about ensuring constants and letters stick together appropriately. And the last one was always remember to sort your signs at the end regardless of which you use. Now, as I mentioned before, these are not two exhaustive methods. They're not the only two ways of doing it. If you have another way, stick with it. If you prefer either of these two ways, jump in with both feet and have a go. Remember, the point is we want to be able to do this properly. Remember, think smart, solve fast.